For thousands of years, humans had iron beneath their feet, but they had no idea how to use it. Then, somewhere in the ancient world, people combined ordinary-looking rock with charcoal, fire, and air inside a primitive furnace. What came out did not look valuable. It was dark, rough, full of impurities, almost like burned stone. But then, someone struck it with a hammer, and with every blow, that strange black mass began turning into something humanity had never possessed before. A new kind of metal. One that would eventually transform farming, warfare, tools, trade, and entire civilizations. But how did ancient humans discover iron when they had no knowledge of modern chemistry, no thermometers, and no idea what was happening inside their furnaces? The story begins before humans ever learned to extract iron from the ground. Long before the Iron Age, people had already encountered iron from an extraordinary source: the sky. Some meteorites contain iron and nickel, and when these strange metallic rocks fell to Earth, ancient people discovered that pieces could be hammered into small objects. Imagine finding a rock unlike anything around you. It shines differently. It feels unusually heavy, and when struck repeatedly, instead of simply breaking apart, it can slowly be shaped. To ancient people, this metal must have seemed almost magical. But meteorite iron had one enormous problem. It was incredibly rare. Humans knew iron existed. They could even work small quantities of it. But if iron was ever going to become useful on a large scale, they needed another source. And that source was hiding inside the earth. Iron ore. To us, an iron-rich rock may simply look red, brown, black, or yellow. But ancient metalworkers faced a much harder problem. Knowing that a rock contained iron was useless unless they could somehow separate the metal from everything else inside it. They already had experience with metals such as copper. Ancient craftsmen had learned that certain rocks changed when exposed to intense heat. Eventually, they discovered ways of extracting copper from ore. Iron, however, was much more difficult. A normal campfire could not simply melt iron into a convenient pool of liquid metal. Even early furnaces often could not reach iron's melting point, so the discovery of iron probably was not one dramatic accident made by a single person. It was likely the result of generations of experimentation. One group tried a different rock. Another added more charcoal. Someone changed the shape of the furnace. Someone else forced more air into the flames. Most attempts probably failed. But failure was teaching them. Imagine an ancient workshop at sunset. Workers crush dark iron-rich stones into smaller pieces. A tall clay furnace stands nearby. Inside it, they place layers of charcoal and ore. The charcoal is lit. At first, the fire burns red. Then workers begin pumping bellows. Air rushes into the furnace. The fire becomes hotter. Orange flames roar upward. Sparks escape through cracks in the clay. Smoke fills the air. Inside the furnace, a chemical process is taking place that nobody there can see or understand. The charcoal helps create gases that remove oxygen from iron compounds in the ore. Slowly, metallic iron begins forming. Hours later, the furnace is opened. But there is no shining sword waiting inside. Instead, the workers discover a hot, ugly, spongy mass mixed with slag and other impurities. This is called an iron bloom. At first glance, it hardly looks like the beginning of a technological revolution. Then comes the most important step. Hammering. The bloom is heated again. A smith places it on a hard surface. He raises his hammer. Strike. Sparks fly. Strike again. The metal begins compressing. It is reheated. Turned. Hammered again. With each blow, more unwanted material is forced out. Gradually, the rough bloom becomes denser and more workable. And now the smith can begin shaping it. A knife. A spearhead. An axe. A farming tool. For the first time, rock pulled from the ground could become something strong enough to transform everyday life. But iron did not immediately replace bronze. Bronze was already an excellent material. Ancient craftsmen had spent centuries learning how to produce beautiful and effective bronze tools and weapons. The problem was supply. Bronze usually required copper combined with tin. Copper could be found in many places. Tin was much harder to obtain. Some civilizations depended on trade routes stretching across enormous distances just to acquire it. Iron ore was different. It was far more widespread. Once people learned how to smelt and forge it reliably, communities had access to a metal source much closer to home. That changed everything. Furnaces became more efficient. Smiths became more skilled. They learned how repeated heating and hammering affected the metal. They discovered that controlling carbon could create harder forms of iron and eventually early steel. Knowledge spread from workshop to workshop, from village to village, from kingdom to kingdom. Iron tools helped farmers work land. Iron axes helped clear forests. Iron weapons changed armies. Ironworking supported expanding settlements and growing economies. But perhaps the most impressive part of the story is how little these early craftsmen understood scientifically. They could not see atoms. They did not understand oxygen. They did not know the exact temperature of their furnaces. They had no textbooks explaining metallurgy. They had only observation, experimentation, memory, and patience. Someone noticed one rock behaved differently. Someone tried more charcoal. Someone pumped more air. Someone refused to throw away the strange black lump inside the furnace, and someone struck it with a hammer. Again and again. Iron was not discovered in one magical moment. Humanity learned to control it slowly. One furnace, one mistake, one breakthrough, and one hammer strike at a time.